Imagine opening your favorite website, the one you visit every morning for news, shopping, or inspiration. Everything you see and interact with on that site, from the crisp layout to the buttons you click, is the result of front-end development. This field, often called front-end systems, lies at the very heart of digital user experience. It is where the visual world of the web comes alive, translating technical plans and user-centered design into efficient, interactive, and visually appealing interfaces. The evolution of front-end systems is a story of steady transformation. In the late 20th century, web development began with static HTML, pages, a digital landscape that was, for the most part, read-only. The earliest websites offered little more than text and simple images, organized with the help of HTML, or hypertext markup language. This language, invented alongside the World Wide Web by Tim Berners-Lee, provided the foundational structure of web pages. The introduction of browsers such as Mosaic and Netscape soon followed, making the web more accessible to a growing audience. Despite these early advances, the web remained largely static. It was not until the mid-1990s that a pivotal shift occurred. JavaScript arrived in 1995, bringing interactivity to what had previously been passive pages. Suddenly, web pages could respond to user actions. Think of forms that validate your input or images that change when you hover your mouse. The following year, CSS, or cascading style sheets, was introduced, giving developers far greater control over the visual style of web pages. As a result, websites became more aesthetically pleasing and dynamic, moving beyond simple layouts to embrace a new world of color, typography, and design. With these tools in place, the distinction between front-end and back-end development began to take shape. The front end became the client side, the part of a website or application that users see and interact with, including buttons, graphics, and text. In contrast, the back end emerged as the server side, the invisible machinery that manages data, processes requests, and often interacts with databases. Back-end developers code the APIs that fetch and deliver data, while front-end developers present that data in ways that are engaging and accessible to users. This division of labor is now fundamental to modern web development. It is important to understand that front-end development did not appear overnight. The dedicated front-end position emerged as a response to the evolving needs of web services. As websites grew more complex and interactive, it became clear that specialized skills were needed to bridge the gap between technical systems and the expectations of end users. Front-end engineers became key collaborators, working closely with back-end and design teams to ensure that the user interface was not only visually attractive, but also intuitive and efficient. At the core of front-end systems are three fundamental technologies: HTML, CSS, and JavaScript. Think of these as the backbone of every website and web application. HTML provides the structure organizing content into headings, paragraphs, images, and links. CSS adds visual flair, enabling developers to define colors, fonts, spacing, and even responsive layouts that adapt to different screen sizes. JavaScript, meanwhile, brings web pages to life, making them interactive and dynamic. Together, these three coding languages form the essential building blocks of the front end. All modern libraries and frameworks, whether it is React.js, Angular, or Vue, are built on top of this foundation. The process of creating a front-end experience is both art and science. It begins with gathering requirements and understanding what users need. Designers then create wireframes and mockups, visual blueprints that outline the look and feel of the interface. Front-end developers translate these designs into code, using HTML, CSS, and JavaScript to build the actual user interface. The journey does not end there. Testing and optimization ensure that the site performs well across different devices and browsers. User testing gathers feedback to identify areas for improvement. Finally, the front end is deployed for users to access, with ongoing maintenance to keep everything running smoothly. A crucial objective of front-end development is to bridge the gap between complex technical systems and the people who use them. Usability and accessibility are not just buzzwords, they are fundamental goals. A well-crafted front end ensures that users, regardless of their background or abilities, can navigate, interact with, and benefit from web applications. This focus on the user is what sets front-end development apart, making it both challenging and deeply rewarding. Over the years, front-end technologies have continued to evolve. In the early days, simple scripts and style sheets were enough, but as user expectations grew, so did the complexity of the systems. Today, over 95% of websites use modern web technologies, reflecting just how central front-end development has become. Choosing the right technologies is now a strategic decision, one that can make or break a website's success. The way users interact with a web application and their satisfaction with the experience is directly shaped by front-end choices. In 2026, front-end development is more crucial than ever. A beautiful, fast, and intuitive front-end is essential for engaging and retaining users. Front-end engineers are no longer working in isolation. They are strategic partners, collaborating closely with back-end and design teams to shape the entire digital experience. As websites and applications grow more sophisticated, the importance of front-end systems only increases. Yet, for all its progress, the foundation of front-end development remains unchanged. HTML, CSS, and JavaScript continue to serve as the pillars of the web, supporting everything from simple blogs to the most advanced web applications. These technologies define not only how a website looks, but also how it feels and functions. They are the invisible hands shaping our everyday digital interactions. As we look to the future, the role of front-end systems will likely continue to expand. But no matter how advanced the tools become, the mission remains the same: to create user interfaces that are visually appealing, user-friendly, and efficient. In doing so, front-end development bridges the worlds of design and technology, ensuring that the web remains a place where everyone can participate, create, and connect. Imagine a bustling web application, crowds of users pouring in, clicking, swiping, entering data, and expecting every interaction to work seamlessly. Behind this apparent simplicity lies a careful choreography, the architecture of the front-end system. As front-end engineering has matured, developers have devised new ways to organize the increasingly complex code that powers these digital experiences. What began as a straightforward task has grown into a sophisticated discipline, driven by the need for modularity, automation, and maintainability. At the heart of front-end architecture is the desire to bring order to chaos. Early on, one of the most influential patterns to emerge was the Model View Controller, or MVC, architecture. Widely adopted in the early days of web application development, this approach divides an application into three interconnected parts. The model manages business data and logic, the raw information and rules that underpin an application's behavior. The view handles presentation, shaping how information appears to the user. The controller acts as a bridge, coordinating user input and determining how that input should affect the model in view. By separating these concerns, MVC makes it easier to develop, scale, and maintain large applications. Business logic lives in its own compartment, while the user interface and interaction logic each have their own domains. This separation allows teams to work in parallel and makes it less daunting to update or extend one part of the system without inadvertently breaking another. While the MVC pattern proved invaluable, the demands of modern web applications soon outgrew its original form. Applications became more interactive, data-rich, and dynamic. Developers sought ways to further modularize code, enhance reusability, and improve collaboration. Out of this need, new architectural paradigms began to emerge. Among them, component-based architecture took center stage, introducing a new way of thinking about user interfaces. Component-based design, popularized by frameworks like React, treats the user interface as a collection of independent, reusable units components. Each component encapsulates its own logic, presentation, and state. Instead of nesting logic in a hierarchical fashion as with MVC, components are arranged more like building blocks. They can be mixed, matched, and reused across different parts of an application. This modularity not only encourages cleaner code, but also enables front-end teams to build, test, and deploy features more efficiently. Angular, once rooted in the MVC tradition, evolved to embrace component-based architecture as well, reflecting the industry's shift toward more granular modularity. Of course, MVC and component-based architectures are not the only models in play. Modern front-end systems may adopt monolithic, modular, micro-front-end, Flux, or hybrid approaches. The choice of architecture depends on the project's complexity, scalability requirements, and long-term maintainability. For example, micro-frontends allow large organizations to divide a single application into independently deployable pieces, each managed by a different team. Other patterns, like Flux, introduce unidirectional data flow to simplify how state is managed and updated across the application. The landscape is diverse, reflecting the many challenges and preferences that shape contemporary front-end development. These architectural approaches come to life through frameworks and libraries, collections of tools, components, and templates that help developers implement best practices and streamline the building process. The emergence of JavaScript frameworks was a direct response to rising complexity and the need for maintainable, scalable code. Through automation, modular development, and standardized workflows, these frameworks have become essential to modern front-end engineering. Among the most popular frameworks in 2024 are React, Angular, and Vue.js. Each brings its own philosophy and strengths to the table. React, developed by Facebook in 2013, is often described as a library rather than a full-fledged framework, but its influence is unmistakable. React's core idea is the reusable component, paired with a virtual DOM, lightweight representation of the actual document object model. This virtual DOM enables React to efficiently update only the parts of the interface that change, leading to faster performance and more responsive user experiences. React's flexibility is one of its hallmarks, allowing developers to pick and choose from a rich ecosystem of supporting libraries for tasks such as state management, routing, and data fetching. Angular, introduced by Google in 2010, takes a more structured, opinionated approach. It began as an MVC framework but evolved to embrace component-based architecture and the model, View Model, MVVM, pattern. Angular is often favored by large enterprise-scale projects due to its comprehensive tooling, strict conventions, and integrated features. It offers everything from form handling and dependency injection to powerful data binding and robust testing utilities. This structure helps teams maintain consistency across vast code bases, making Angular a strong choice for organizations that value predictability and built-in best practices. Vue.js, created by Evan You in 2014, positions itself as a progressive framework, aiming to provide the best of both worlds, the structure of a framework and the flexibility of a library. Vue is approachable, with a gentle learning curve, yet it offers sophisticated features for managing complex applications. Like React, Vue uses a virtual DOM and organizes user interfaces into components. Its internal structure includes a compiler and renderer, as well as mechanisms for state management and reactivity. Vue's popularity has grown steadily, especially among developers seeking a balance between structure and flexibility. Other frameworks and libraries such as Svelte and Knockout.js have also made their mark. Knockout.js, for example, allows developers to implement the MVC pattern with data binding and can even be used alongside other frameworks like React. The field continues to evolve, with new tools emerging to meet the needs of different teams, projects, and business goals. Choosing the right framework is rarely a matter of popularity alone. Performance, ecosystem maturity, and developer experience all play a role. React's ecosystem is vast and diverse, making it highly adaptable. Angular's all-in-one toolkit and patterns appeal to enterprises with large teams and complex requirements. Vue's progressive adoption model suits both small projects and ambitious applications. Framework usage often varies by company size, project scope, and the specific challenges at hand. Underlying all of these frameworks and architectures is a drive to systematize and automate front-end development. Node.js, for instance, played a pivotal role in advancing the field by enabling JavaScript to be used for toolchains, environment management, and automation tasks. Modern front-end engineering relies on continuous integration and delivery, version control, performance optimization, and close collaboration among team members. These practices, supported by the architectures and tools described here, allow front-end systems to scale and adapt as user expectations and technologies continue to evolve. As we move deeper into the world of front-end development, it becomes clear that the architecture of a system is not just a technical decision. It shapes how teams work, how products grow, and how users experience the web. The frameworks and patterns we choose lay the groundwork for innovation, reliability, and ultimately, the delight of those who interact with our creations. Step into the workspace of any modern front-end developer and you will sense a distinct hum of activity powered by a carefully selected array of tools. Efficiency, collaboration, and scalability are at the core of successful front-end systems, and the right toolkit is essential for achieving these goals. In today's landscape, certain tools have become nearly universal. Git and platforms like GitHub are foundational, allowing developers to track changes, collaborate across distances, and safely experiment with new features. Visual Studio Code, or VS Code, is the editor of choice for many, valued for its balance of power and approachability, its extensive plugin ecosystem, and its ability to adapt to the unique needs of every project and developer. But the toolkit extends beyond these essentials. Developers often rely on specialized utilities to enhance their daily workflow. Raycast, for example, provides lightning-fast command execution and app launching, while tools like iTerm and NeoVim appeal to those who prefer speed and a minimalist, keyboard-driven environment. The Arc browser is a favorite for its focus on organization and productivity, supporting the multitasking demands of front-end work. Chrome Developer Tools remains an indispensable companion, offering real-time insights into performance, debugging, and the inner workings of web applications as users experience them. For styling, preprocessors like SAS streamline the process of writing and maintaining CSS, enabling variables, nesting, and a modular structure that pure CSS lacks. On the utility-first frontier, Tailwind CSS allows developers to rapidly prototype and build interfaces with consistency and speed, all while keeping style sheets lean and maintainable. As projects grow more ambitious, the ecosystem expands to include advanced tools like React Developer Tools for component inspection, Figma for collaborative design, and Node.js with NPM, the Node Package Manager for managing dependencies and running server-side JavaScript. The modern front-end workflow is a finely tuned machine. Build tools such as Vite, Webpack, and Parcel automate the bundling and optimization of code, transforming source files into efficient, production-ready assets. These tools handle tasks like code splitting, minification, and asset management behind the scenes, freeing developers to focus on features and user experience. Static site generators like Astro are gaining popularity, offering a streamlined way to produce fast, content-driven sites. For testing, platforms such as Playwright provide robust frameworks for automating browser-based tests, ensuring reliability and consistency across browsers and devices. Hosting and deployment, once a tedious process, are now simplified by services like Netlify, which automate the journey from build to deployment, often with a single click or a Git push. API testing is another essential piece of the puzzle, and tools like Insomnia help developers validate endpoints, manage requests, and debug integrations with ease. Collaboration is further supported by platforms such as Pullflow, which integrates with GitHub, Slack, and VS Code to streamline team communication and code review. Even the design process is tightly integrated, with Figma serving as a collaborative canvas where designers and developers share ideas, iterate on interfaces, and align on a shared vision. These tools are more than just conveniences. They are fundamental to addressing the unique challenges of front-end development. As teams grow and projects scale, the need for maintainable, organized code becomes paramount. A consistent folder structure and clear code organization help teams avoid confusion, minimize bugs, and onboard new members more easily. Enterprises, in particular, depend on carefully crafted architectures that combine modular component design, scalable state management, and adherence to a unified design system. This ensures user interface consistency and enables applications to be extended without descending into chaos. Scalability is not just about handling more users or increased traffic, it is about organizing code in teams so that complexity remains manageable as the application and the business evolve. Modular code organization allows different parts of the system to evolve independently, reducing bottlenecks and making it easier to update or replace features. Some organizations adopt domain-driven design or even monorepo structures, where all related code lives in a single repository, making cross-team collaboration and coordination more efficient. Collaboration is the lifeblood of front-end systems, especially at scale. Successful teams do not just write code, they communicate, share feedback, and synchronize efforts across roles and disciplines. The relationship between front-end developers and designers is especially critical. Early involvement in the design process, the use of shared collaboration tools, and the establishment of documented guidelines all contribute to smoother handoffs and a consistent user experience. For cross-functional teamwork, clear communication practices, application programming interface, first development, and component-driven workflows help synchronize expectations and reduce friction. Synchronized data contracts, formal agreements on how data will be structured and exchanged, are vital to ensuring that front-end and back-end systems mesh seamlessly. Best practices for maintainability and scalability often center on the same principles: clarity, modularity, and documentation. Code should be easy to read and follow, with clear separation of concerns so that each part of the system has a well-defined purpose. Design systems serve as a shared language between teams, encapsulating everything from color schemes and typography to reusable components and interaction patterns. This not only speeds up development, but also ensures that the user interface remains cohesive as new features are added. The tools and practices of front-end development are always evolving, driven by new technologies and changing user expectations. In 2024, trends such as WebAssembly are pushing the boundaries of web performance, allowing code written in languages like Rust or C++ to run in the browser at near-native speed. Frameworks continue to advance, with React 18 introducing features like automatic batching and concurrent rendering to further improve performance, and Angular 16 refining its Ivy rendering engine for faster, more efficient updates. Amid these advances, there is a growing emphasis on accessibility and developer experience, ensuring that web applications are usable by everyone and that developer workflows remain productive and enjoyable. Continuous learning is not just encouraged, it is essential. Front-end technologies evolve rapidly, and teams must stay updated to remain effective. Strategies for ongoing education include setting clear learning goals, tapping into diverse resources, and engaging with the wider developer community. This might involve joining online forums, participating in pair programming sessions, or even teaching others, all of which reinforce knowledge and foster a culture of growth. Improving developer experience is not just about adopting the latest tools, but also about creating an environment where learning and experimentation are part of the everyday workflow. A modern front-end development platform brings all these elements together, centralizing tools, standards, and processes for building, testing, and deploying user interfaces. Such platforms help teams navigate the unique challenges of front-end work, from managing dependencies to orchestrating complex builds, testing interfaces, and deploying updates swiftly and safely. In this ecosystem, no tool or workflow stands alone. Each is part of a broader system, carefully chosen and refined to support the ultimate goal, building fast, reliable, and delightful user experiences at scale. As the field moves forward, the interplay between tools, workflows, and best practices will only grow in importance. Teams that invest in the right foundations, embrace continuous learning, and prioritize effective collaboration are best positioned to thrive in the ever-evolving world of front-end systems. Speed and responsiveness are the twin engines that power every successful front-end system. For users, even minor delays can mean the difference between delight and frustration. It is no surprise, then, that optimizing performance is both an art and a science, a process of continual refinement, measurement, and adaptation. At its core, front-end optimization is about trimming excess, streamlining how resources are delivered and rendered, and ensuring every interaction feels effortless. One of the first defenses against sluggishness is minimizing the number of HTTP requests a browser must make. Every image, script, or style sheet fetched from a server adds a small but cumulative delay. Developers seek ways to combine or defer these resources so the browser can get what it needs as quickly as possible. Images are a prime target for optimization, serving them at the right size, compressing them without noticeable quality loss, and using modern formats all help pages load faster and use less bandwidth. Code minification, removing unnecessary spaces, comments, and even shortening variable names in CSS and JavaScript also shaves precious milliseconds off load times. The global nature of the internet means users might access your site from anywhere, and that is where content delivery networks, or CDNs, come in. By distributing copies of assets to servers around the world, CDNs ensure that data travels the shortest possible distance, reducing latency. Similarly, enabling browser caching allows frequently used files to be stored locally, so returning visitors do not have to download them again. Even server response time matters. A sluggish backend can bottleneck the entire experience, so efficient server configurations and quick data retrieval are essential. As front-end applications grow in complexity, broad strategies give way to more scalable, targeted techniques. Code splitting is a prime example. Rather than sending the entire application to the browser up front, code splitting breaks it into manageable chunks, loading only what the user needs at any given moment. This reduces initial load times and makes large applications feel snappier, especially on slower networks or less powerful devices. Selective rendering follows a similar approach, updating only the parts of the interface that truly need to change, which conserves both bandwidth and processing power. JavaScript, the engine behind most interactive features, can be a double-edged sword. On one hand, it enables dynamic, engaging experiences. On the other, it can bog down performance if not handled with care. Efficiently updating the document object model, or DOM, by minimizing changes and batching updates helps keep the browser from working overtime. Selective script loading ensures that only essential JavaScript runs on initial page load, deferring less critical scripts until later. Minification keeps downloads small, while asynchronous operations prevent scripts from blocking the browser's rendering pipeline. Proper memory management and event handling keep applications responsive, even as users click, scroll, and type rapidly. The quest for performance does not stop at theory, it is grounded in measurement. Tools such as Google Lighthouse and Web Vitals provide detailed insights into how real users experience a site, from page load speed to interactivity and visual stability. Other platforms like Sentry, LogRocket, and New Relic Browser help developers track performance issues as they arise in production, creating a feedback loop for continual improvement. These monitoring and observability tools are essential for maintaining uptime, catching regressions, and ensuring that optimizations truly make an impact. Prefetching and priority-based loading are additional strategies that anticipate user needs. By predicting which resources or data a user is likely to need next, the system can quietly fetch them in the background, reducing wait times when they are actually requested. Assigning priorities to assets, ensuring above-the-fold content loads first, for instance, makes sure users see something useful as quickly as possible. All of these practices have tangible business benefits. Faster sites have been shown to increase user engagement, improve conversion rates, and boost search engine rankings. But performance is only part of the equation. To guarantee that front-end systems behave as expected, thorough testing is essential. Testing in the front-end world is more than just checking for typos or broken buttons. It is about ensuring that every component, interaction, and integration works reliably across a dizzying array of devices, browsers, and network conditions. Best practices begin with writing effective tests, clear, maintainable scripts that verify both the basics and the edge cases. Automation is a force multiplier here, allowing teams to run large test suites quickly and consistently, catching bugs before they reach users. Coverage matters too. Good tests should touch all the critical paths in an application, minimizing the chances that a change in one area will cause unexpected issues elsewhere. Testing is not a one-off task, but an ongoing activity woven throughout the development process. Separate teams may specialize in security and performance testing, bringing fresh eyes and expertise to bear. Simulating end-user environments, different devices, screen sizes, operating systems helps uncover subtle bugs that only appear in the wild. Mimicking the developer environment ensures that issues are not introduced by differences in setup or tooling. When developers make significant changes to the codebase, focused testing ensures those changes do not break existing features. Automated regression cycles, repeating sets of tests, help catch issues that might otherwise slip through the cracks. The most effective testing strategies build on each other, starting with basic checks for component presence, then layering on more complex scenarios that reflect real-world use. Quality assurance is not just about finding bugs, but about building confidence. It is a collaborative process involving developers, testers, and stakeholders throughout the development lifecycle. Ongoing testing and monitoring help teams catch problems early before they can impact users or damage trust. Yet even the most performant and reliable front-end systems can be undone by security lapses. The open nature of web applications, exposing code and data to anyone with a browser, makes them attractive targets for attackers. Common risks include cross-site scripting, where malicious code is injected into otherwise safe pages, clickjacking, which tricks users into clicking on hidden elements, geolocation stealing, and unauthorized crypto mining using the user's device. To guard against cross-site scripting, rigorous input sanitization and filtering are essential. Never trust data from users or external sources. Cross-site request forgery is another frequent threat, where attackers trick users into performing actions they did not intend. Protecting against these and other vulnerabilities means adopting secure coding practices, keeping up with evolving threats, and following established guidance like the OWASP Top 10, which highlights risks such as broken object-level authorization and authentication. Security must be baked into the development process, not bolted on at the end. According to industry surveys, approximately 74% of companies have reported insecure coding practices leading to breaches. Protecting user-facing code, HTML, CSS, JavaScript, and client-side storage requires vigilance, regular audits, and education. As technology continues to advance, so do the tactics of those looking to exploit weaknesses. Front-end security is a moving target, demanding that teams stay informed and proactive. By combining robust optimization techniques, thorough testing, and vigilant security practices, developers can create front-end systems that are not just fast and beautiful, but also trustworthy and resilient. The result is an experience that users can rely on, and a foundation that supports growth, innovation, and peace of mind in an ever-changing digital landscape. If you pause to consider the state of front-end systems today, you will notice a landscape undergoing rapid transformation. Tools and techniques that once seemed cutting-edge now share the stage with a new wave of innovation. The future of front-end development is not just about building faster or more attractive interfaces. It is about reimagining what is possible at the intersection of technology and human experience. Listeners curious about where this field is heading will find that the story is shaped by emerging trends such as single-page applications, progressive web apps, micro front-ends, motion user interface, and a host of advances in automation and artificial intelligence. Take the rise of single-page applications, or SPAs, which continue to define how interactive web experiences are created. Frameworks like Angular, React, and Vue are driving this trend, enabling developers to deliver seamless, app-like navigation without the disruptive reloads of older web pages. But the evolution does not stop there. React, for example, is not only a staple for building SPAs, it is also advancing to support more sophisticated methods for creating progressive web apps and enabling server-side rendering, both of which are influencing how users interact with the modern web. Progressive web apps, or PWAs, demonstrate how front-end systems are blurring the lines between websites and native mobile applications. PWAs leverage the latest web technologies to offer robust offline functionality, lightning-fast load times, and features traditionally reserved for mobile apps, such as push notifications and device integration. The impact is clear. Companies adopting PWAs often see reduced development costs, streamlined updates, and improved search engine optimization, since these apps are easily discoverable by search engines. Users benefit from the convenience of accessing powerful, app-like experiences directly from their browsers, whether they are on the subway with spotty reception or at home with a high-speed connection. Major platforms like Spotify and Microsoft Outlook have already adopted PWAs, highlighting their growing significance in the web ecosystem. Another important shift is the move toward micro front ends. This architectural pattern breaks large web applications into smaller, independently deployable pieces, each often managed by a separate team. Such modularity encourages agility and scalability, allowing organizations to iterate quickly and deliver new features without disrupting the entire system. As digital products become more complex, the micro front-end approach helps teams manage that complexity by establishing clear boundaries and making it easier to onboard new developers or experiment with different technologies within the same product. What unites all these advances is not just a pursuit of technical novelty, but a deeper commitment to user experience. Motion user interface, for instance, is becoming a signature of engaging interfaces, enabling designers and developers to use subtle animations and transitions to guide attention, provide feedback, and create a sense of delight. Innovations like JAM, stack-in architecture built on JavaScript, application programming interfaces, and markup are also making it easier to deliver content quickly and securely, resulting in faster, smoother web interactions. Perhaps the most profound transformation in front-end systems is being driven by artificial intelligence. Artificial intelligence-powered chatbots are now a familiar presence across websites, offering instant support and personalized recommendations. But artificial intelligence's influence goes much further. In 2024 and beyond, intelligent tools like GitHub Copilot, ChatGPT, and Tab9 are becoming standard companions for front-end developers. These artificial intelligence-powered assistants can draft code, suggest fixes, optimize performance, and handle repetitive boilerplate tasks. By 2026, such assistants are expected to evolve from helpful sidekicks to true partners, capable of recommending architectural changes and automating large portions of the development process. Artificial intelligence's impact is not limited to code generation. Machine learning is increasingly used to automate code reviews, prototyping, and testing. Tools like Sketch-to-Code can convert wireframes and sketches directly into HTML prototypes, dramatically reducing the time from concept to working interface. This automation not only increases efficiency, but also frees developers and designers to focus on creative and strategic challenges instead of repetitive chores. WebAssembly is another technology expanding what is possible in the browser. By allowing code written in languages like Rust or C++ to run at near-native speeds, WebAssembly enables more interactive and computationally intensive applications on the web. For users, this means richer experiences, from advanced graphics to real-time data processing delivered seamlessly through the browser without the need for plugins or external downloads. Accessibility is also becoming a central focus in front-end development. Voice user interfaces, or VUIs, are gaining importance, making it possible for users to navigate and interact with web applications using speech. Artificial intelligence-powered tools are helping automate accessibility testing, identifying potential barriers, and ensuring that digital experiences are usable by as many people as possible. This shift is not just about compliance, it is about recognizing the diverse ways people engage with technology and making inclusion a core part of the development process. Tooling continues to advance rapidly. The front-end ecosystem in 2024 is rich with solutions for styling, state management, and build optimization. Technologies like Redux, Zustan, MobX, Tailwind, CSS, Bootstrap, Webpack, Parcel, ES-Build, TypeScript, WebAssembly, and serverless functions are empowering developers to build more maintainable, efficient, and scalable systems. There is a growing trend toward TypeScript standardization, bringing type safety to JavaScript and reducing the likelihood of bugs. Meanwhile, serverless functions make it easier to run back-end logic without managing infrastructure, further blurring the lines between front-end and back-end responsibilities. As these tools and patterns evolve, so does the craft of front-end development. The demand for skilled front-end developers remains high, but the essentials, a solid grasp of HTML, CSS, and JavaScript, continue to form the foundation upon which everything else is built. What is changing is the expectation that developers will be comfortable learning and adapting to new technologies throughout their careers. That is why continuous learning is more important than ever. To keep up with the evolving landscape, front-end teams are encouraged to set clear learning goals, draw from a wide range of resources, and actively engage with the broader community. Participating in online forums, pair programming, and teaching others are practical strategies for staying current and deepening expertise. The most successful teams and individuals are those who embrace learning as an ongoing journey, not a destination. The horizon for front-end systems is both exciting and unpredictable. New advances in artificial intelligence, automation, performance optimization, and accessibility will continue to reshape the field in ways that are difficult to fully anticipate. But one thing remains certain: the core mission of front-end development, creating experiences that are fast, accessible, and delightful, will continue to drive innovation. Those who remain curious, adaptable, and committed to learning will not only keep pace, but help shape the future of how people interact with the digital world.